This is the second video in the sequence on numerical methods. It's Rearranging College Maths, Year 2, Pure 6, and we're covering iterative formulas. So once we found that we have a root between two particular values of x, often we want to zoom in on where that value is, and those limits will give us a starting point. But what we're going to use is a formula, an iterative formula, and we're going to look to see if our equation can be rearranged to the form where we get x on one side of the equation and a function of x on the other side of the equation. So for example, if we had x equals a half 1 over x plus 5, then what we do is we say the function, we're going to put a value of x into our function, and that's going to give us a new value of x. So we actually write our formula like this. So we first of all say we're going to have a value of x1. We're going to get a sequence of estimates for our root x. So this is going to be our initial estimate. We're going to put it in here. So we're going to say n is 1. We're going to put it in there, and we're going to get x2 out. So here's our formula. Find the first four terms of the sequence. The sequence converges to a limit. Find this limit. So what we're going to do now is we're going to say if x1 is 1, x1 equals 1, x2 is equal to a half times 1 over, well, we need x1, don't we, plus 5. So that's a half times 1 over, our x1 was 1 plus 5, which is a value of 3. And then we can do the same with x3. It's going to be a half times 1 over x2 plus 5, which is a half times 1 over 3 plus 5, which comes out to 8 over 3. x4. So let's see how to do this on the calculator. So I'm going to switch to the calculator now. And what we're going to do is we're going to start off by putting in our initial estimate. So we're going to say 1, and we're going to press equals. That's our x1. Now we're going to put in the formula using this answer button. So I'm going to put in, let's do it exactly as we've got it written there. So 1 over 2 multiplied by, then in brackets, again we've got a fraction, 1 over, and now we're going to put in answer as our previous estimate, as our xn, plus 5. I'm a bit slow clicking the buttons on this calculator emulator. So now when we press equals, it's going to be putting 1 in here. So press equals, and we get the 3 that we've already seen. Press equals again now, and it's putting that 3 in the formula for us. So we get 8 over 3 as we've seen. So that's our x3. x4 is 43 over 16. 43 over 16. And then we can just keep going. So we found the first four terms of the sequence, which is what the question asked us to do. It says the sequence converges to a limit. Find this limit. So we're going to find that limit by keeping pressing equals. So that's our x5, x6, x7, x8, and so on. And you can see now we've got 2.686, 2.68614. If we keep pressing again, it's still 2.68614, and what's changing is just those, I think it's about the 6th, 7th, and 8th decimal places. So that's probably accurate enough for us, isn't it? If we press equals again now, it's not changing. So limit equals 2.68614. That's quite enough for the moment. We could write 2.686 to 4 significant figures. We can find it to whatever accuracy we think is appropriate or we're asked for. Okay, so let's look at the second example. Let's go through this maybe a little bit quicker. So here we've got x1 equals minus 4. x2, let's write out x2 and x3, and then let's find what the limit is. So again, we're going to do it on the calculator. So if we go and clear this, so we've got x1 is minus 4, so minus 4 equals, and then our xn is the cube root, so we're going to go shift cube root of 7 times answer minus 1 and press equals. So our first or our next estimate, x2, is minus 3.0723. Let's just give it to 4 decimal places for the moment. Press equals again. That's now our x3 is minus 2.823. What have we got? 368. So 4 to 4 decimal places. And if we keep pressing equals, what we're interested in is once maybe that third or fourth decimal place stops changing. So minus 2.725, minus 2.717, minus 2.715, minus 2.714. So the 7.1 is changing, so we've now not changing. We've now got 7.14, 7.145. So it looks like the limit is minus 2.7145 to 4 decimal places, or 5 significant figures. Again, I'm not suggesting that 5 significant figures is necessarily appropriate accuracy. Generally speaking, you'll get told in an exam question what accuracy to give this to, and if you're not told, then 3 significant figures is probably what you should choose. So let's now look quickly at, for the question 3, for the equation x cubed equals 10, find 2 possible iteration formulas. So what we could do is, first one, we're going to, well, for both of these, we're going to start with x cubed equals 10. What I'm going to do now is I'm going to divide both sides by x. So we're going to say x squared is equal to 10 over x. And then I'm going to take the square root. So I'm going to say x is equal to positive square root of 10 over x. And I'm going to make that my iterative formula. So we're going to say, so x n plus 1 is equal to positive square root of 10 over x n. Once I've chosen my starting point, my value of x1, it's going to go in there, work that out, that'll give me my x2. A second way of doing this, number 2, again, if we start with x cubed equals 10, here what I could do is I could just divide both sides by x squared, and then I could write x is equal to 10 over x squared, and this gives me another formula. So I've now got x n plus 1 is equal to 10 over xn squared. So we've got two possible rearrangements of x cubed equals 10 to find iterative formulas.